Hey everyone, and welcome back to the channel. We have spent a lot of time talking about the magic of caching. How a single cache can dramatically speed up your application. But what if one cache isn't enough? What if you could combine multiple caching mechanisms, each optimized for different needs, to create an even more robust and lightning fast system? Today, we are diving into layered caching, the ultimate strategy for maximizing performance and resilience in complex applications. Get ready to build caching superpower. So, what is layered caching? At its core, layered caching, also known as multi-tier caching or multi-level caching, is the strategy the strategic implementation of multiple distinct caching layers within your system architecture. Instead of relying on a single cache, you deploy different types of caches at various points in the data flow, each with its own characteristics, advantages, and optimal use cases. Think of it like a series of defense wall around your most valuable treasure. Your database, the outermost layer, or the fastest and the closest to the user, holding the most frequent access data or static data. As you move inward, the layers might be larger or more consistent, or um, also might be slightly slower until you eventually reach the database. The goal is to serve data from the fastest, closest cache possible, and only fall back to slower layers or the database if necessary. Okay, so we might give a small example. So let's say that we have our client here. So how our client will use multiple caches layered. For example, it will use like a CDN to cache all the static content like images, videos, CSS scripts, things like that. And when the client sends a request to the server, for example, to read any data, it should be, and the server will read this data, will send a read request to the database. Also, the server could use a cache here. So all the frequently accessed data, like example, user IDs, maybe famous products, things like that, will be stored in this cache. So instead of the server going all the time to the database to read the same data, it will just read them to the cache, and the cache will send it back, and it will be sent back to the client quite faster. So we have two layered here of caches, if you can see. So this is a small example. Okay, so why layered caching is important? The benefits, like there is a lot of different benefits, but we will talk about 5 of them right now. First, maximize performance. Basically, you reduce latency. Like by having caches closer to user, for example, client side cache or CDN, requests are served even faster. If a request misses the first cache, it moves to the next fastest one, constantly minimizing latency before hitting the database. Number 2, reduce backend load. Each caching layer acts as a filter. If a request is satisfied by an outer layer, it never reaches the inner layer of your application, or it doesn't even reaches the database. This significantly reduces the load on your origin servers and databases. 3. Increase scalability and availability. A failure in one cache layer, like an application server's local cache clearing, won't necessarily impact the entire system, as other layers can still serve data. It adds more points of failure, but also more redundancy. Number 4, optimized resource usage. You can use cheaper, smaller, faster caches for the hottest data at the edges, and larger, more consistent, but potentially slightly slower caches deeper in your architecture, optimizing your overall resources. Yeah. And number 5, targeted caching. Different layers can cache different types of data more effectively and efficiently. For instance, a CDN for static assets, a distributed cache for session data, and a database cache for query results. Okay, let's talk about some common layers in layered caching strategy. So let's explore some common caching strategy, caching layers you might implement in a post layered caching strategy, moving from the user inward towards the database. So first we start with the client side cache, which is a browser or device cache. What it caches, it will cache static assets, images, CSS, JavaScript, often dynamic content with short time to lives. Where it lives on users' browser or mobile devices. The pros of it, it's fastest access possible, zero server load. The problem with it is limited space, individual per user, difficult to invalidate perfectly. But two, we have a content delivery network. What it caches is static assets, often static HTML pages, videos, large files. Where it lives, edge servers globally, geographically closer to the user. Pros dramatically reduces latency for global users, offloads origin server massively, offers a DDoS protection. The cons of it is primarily for static content, invalidation can take time to propagate. 3, we have web server or reverse proxy cache. What it caches, full page HTML, API responses, frequently accessed dynamic content that is common across users. Where it lives on your web browser or dedicated server or dedicated reverse proxies, often in front of your application servers. The pros of it reduces load on application servers faster than hitting the app or the database. The cons of it, it can be difficult to invalidate for highly dynamic content. Number 4, application cache, which is in-memory or local cache. What it caches, frequently accessed objects, computed results, user-specific data, where it lives within your application's memory on each individual application server. The pros of it, extremely fast direct memory access. The cons of it has a limited to single server, not shared across instances. Number 5, we have distributed cache. What is it? It's a session. It caches session data, user profiles, shared configuration, aggregated data. Where it lives, a separate cluster of dedicated cache servers accessible by all applications instances. The pros of it, it's shared across all application instances, highly scalable, fault tolerant. The cons of it, network latency involved, needs carefully management for consistency. Okay. Lastly, we have database cache. What it caches, query results, data blocks, often handled automatically by the database itself, where it lives within the database server's memory. The pros of it, optimize database's own operations. The cons of it, limited control, can be invalidated by write to tables. Okay. Let's talk about best practices. So implementing layer caching effectively requires careful planning. One of them, the cache the right data, add the right layer, static assets go to CDN, session data to distribute cache, hot objects to application cache. Don't cache everything everywhere, okay? Number 2, set appropriate time to live. Each layer needs its own time to live policies, tighter time to live for dynamic data, closer to the user, looser time to live for more static content. Number 3, implement cache invalidation strategy. This becomes even more critical and complex across layers. Invalidate from the outermost layer, for example, a CDN, inward for use, or use, for example, pops up message to notify multiple layers. Number 4, I guess we here handle cache messes gracefully. Every layer needs to gracefully fall back to the next slower layer or the database on a mess. Number 5, monitor performance at each layer. Track hit miss ratio, latency, and resource usage for every cache layer to identify bottlenecks and optimize. Lastly, design for consistency needs. Understand your application's tolerance for stale data at each layer. Strong consistency requirements might limit aggressive caching at outer layers. Okay. So in conclusion, layered caching is the pine. Yeah, it's I would say that it's the pinnacle of the pinnacle. Do I pronounce it right or wrong? I don't know, because a lot of times I pronounce things wrong.
Pinnacle.
Pinnacle, yeah, not pinnacle. Okay, so the layered caching is the pinnacle of caching strategy. It's not about just throwing memory at a problem. It's about intelligently orchestrating multiple caching mechanism into cohesive, symphony of speed. By strategically planning caches at different points in your architecture, you can achieve unparalleled performance, scalability, and resilience. Yeah, and resilience ensures your users get the fastest, most reliable experience possible. It's a powerful tool for any high performance system. So that's it for this video, and see you in the future.